Hi, we're going to step through the basics of processing some MX7 data in Applanix POSPac and TBC so we can get it ready for population into Trimble MX Publisher. So we'll be jumping through a few pieces of software here. What I've got is a really basic data set that I've captured with an MX7. These are the files that get generated from inside of Trimble Mobile Imaging. If you're running a newer system, then you'll also see a coverage folder as well to give you a quick KML file of where you've captured your mission. This one was second generation hardware. I like to add a folder here for the base data just to keep it all together. And then I usually also add a folder called POSPac. I add another one called TBC. And later on, we can add some for the Trimble MX data as well. But to begin with, we're going to do this first video that will jump through the POSPac aspect of the processing. Okay. So we'll fire up POSPac. Very similar to Trimble Business Center, runs on the same underlying type of code base, so it's quite familiar to anybody that's used TBC before. We'll just go to a new default project. Don't need to set up too much in here. Not doing any transformations because we're just going to be processing in relationship to the base data. So what we could do is start off by hitting save. We'll go to that folder we had, POSPac, and then I'll put in today's date. Put in whatever you like. Then the next thing we'll do is I'll just extract this and going to drag and drop the T02 file into there. So, okay. All right, we've got that one sitting in there nicely. Go to import and just going to navigate to the POS directory. This is where all of the information that's been recorded by the system is stored. So under raw, hit that. We'll have these POS files, and we don't need to select them all. They have an instruction that tells them to keep importing until they've imported all of them. And we can just select on the first one and choose to import. And we should see our trajectory come in. Now, as part of this, what POSPac will do is go and look for the ephemerides that are available. So if there's precise ephemerides that it can download, it will go through and do that as part of its import process to make sure we're getting the best possible data processing as we step into the next components of this. So we'll let that run for a little while. It will go off and check against various databases. And once it's done those checks, it will download whatever it was able to capture. So if we have a little bit more of a gap between our capture and our processing, then we're able to get a precise ephemeris there. Okay. Now, depending on the system, some of these run different antennas for what we're doing. I'm going to select this TW3870 for the MX7. This was hardware variant number 2. If you're using some other type of system and watching this video, just be sure to align that against the antenna type that you're using. And we'll click OK. All right, so really basic, this one. You can see here was where I did some static and some initialization motions, putting it through some dynamics. And what we're going to do here is, if we have a look at the Project Explorer, we can see here our base stations, and we're going to say set base station. We just need to hit set base station there, and that changes the color of that flag and tells it that that's the one that we're going to use for our processing. Now, in our Project Explorer, just under the GNSS inertial, these lever arms and mounting angles, this relationship of the primary GNSS lever arm, this is the relationship of the IMU to the GNSS antenna that sits on top of the MX7. So we calibrate that from factory. We know that really accurately, so we can drop that down to the smallest possible value of standard deviation there. For the GAMs, however, this is determined from measuring the system. So what we'll do is, in this case, I'm going to leave it at 5 centimeters. I could do another video to show how we process this when it's an unknown value. So we'll leave that for now and accept that at 5 centimeters, being pretty close to what I think I've measured it to, and we'll hit OK there. Now we're ready to jump into the processing. We've got a few different options for processing here. RTX, if we had no base stations around, it is a separate service that we provide. If you purchase that as an additional module, we have the ability to process off multiple single base stations so that they're chained together for long linear projects. And we go through and sort of pre-process a little bit of this. But for what we're doing with just a single base station here and this type of data, go to GNSS inertial. I need to select this infusion single base, and that aligns with the type of IMU and the technology being used in the MX7, which is the AP20. Base station is Kyneton. We're using GAMS, and we can hit run. And what this will do is it will process the forward trajectory, and it will process the backward trajectory as well, so that we get a smoothed best estimate trajectory. So here we could see we've done pretty well. Out of 1,032, we've got 1,032 fixed epochs, a few that are in float, and a couple that did not get a solution. So that's pretty reasonable. We can see here as it processes through, it's able to jump through a couple of different processing modes there. And we should be done. So we can close out of that. In here we start to see this, where we've now got our processed trajectory, this SBET over the top of the original. And we could just see it starts to improve the position of some of these locations up and down, and where we drove to, where we switched it off and on and did a few other maneuvers. And in this case, it's pretty reasonable. Nothing too crazy in there that would suggest any big problems. I always like to, at this point, come in here, turn off the real-time trajectory. So I've just got the post-processed, and I want to turn this on to position RMS. Now looking at this is where we start to get a few little yellow sections. So underneath some tree canopy here, we know that that wasn't performing as well. And we can actually drop these down and say, okay, I want to see these at 0.05, 0.1, 0.3, and 1 meter, then 3 meters. And that should be enough for us to get that to be reevaluated there. And if we update those, we start to see where we're getting those poorer performing sections as we analyze that trajectory. So overall, pretty good all through there. Only a few small sections of yellow. The rest is processed really well, so no need to keep changing the colorizing there. The other component I go through and always have a look at is just under the Reports tab. We'll go to Display Plots. Now we can run a full post-processing report, but this gives us everything we need without the need for doing 100 pages of extra information. So we want the smoothed performance metrics, and what I like to do is have a look at these, and I usually overlay just with Shift and click, and I can grab all three of those together. And so here we could see processed really well. We've got some really nice tight RMS values down through here, nothing really exceeding that 20, 25 mil, little spike through there for easting and northing. For the elevation, we're sitting at around 35 mil as our max with a bit of a spike there, and these ones. Things that always worth having a little bit of a look at is the calibrated installation parameters, and so X, Y, and Z for the GAMs, and just seeing if they align with what our original values were that we had in the project settings. And that's usually part of the initial process to verify our installation. Once we've done that once, we don't really need to revisit that. I like to come in and have a look at this smoothed solution status as well. Just have a look at how the PDOP was, where it wasn't performing quite so well. Have a look at baseline length. This is also a good indicator if we're doing linear jobs of where we might be expecting to get some problems, and especially where the processing mode was flicking. So fixed narrow lane is our RTK type solution. It's a particular way of processing GNSS signals as narrow lane. We've had to go out to wide lane a few times, and then we've got some float where it wasn't able to resolve that all the time. We can have a look at this GAMS solution as well, and this one, 0 is GAMS in use, and then GAMS not in use is where we start to get some deviation around the results, and we have to take it out of the solution to try and improve that trajectory. Lots of other things in there, but they're sort of the ones that I always have a bit of a look at, with these three as being the most sort of critical as to how it's performed in its processing. So at this point, I'm done inside of POSPac. I can hit save and I can close that. Now, if I have a look back into here, I've got my POSPac, and similar to how TPC is structured, we have our project file. In this case, it's a .POSPac and a folder associated to it. And if I have a look in here and go to mission 1 and processed, then down here I will have a file called the SBET mission1.out, and this is our processed trajectory. This holds the SBET, the smoothed best estimate trajectory. Okay, so that's all we need to do with the first component. I'll hit pause on the video and we'll separate this into a second video for the TPC aspect.